logs are not really an easy thing to work with, and although by now I don't have to explain why collecting, storing and processing logs is worthwhile. We all know that logs have immense value. We don't have to explain why to do that, we just do it. IT operational guys find operational issues within logs. IT security guys discover incidents, and also they do their forensics investigations using logs. So we see a lot of value in logs, but still it's not a very easy to it's not an easy thing to work with, because there are serious issues with logs. Like, we do have lots of them. Literally, I have seen projects where hundreds of gigabytes or even a terabyte of logs were collected each day. And the problem is that this kind of data is a DBA's nightmare. So it's not the nice, lean, well-structured kind of data that we like to see in databases. Instead, it's just plain old text that programmers generate and include information that they think is valuable. So they don't really care usually what kind of things we want to do with those data later on. Logs just happen. It's a side effect of software engineering, and programmers usually create logs because they want to be able to troubleshoot their own software, and not because they know what we intend to do with it. There are log standardization efforts that would standardize how logs should look like, but basically they are in vain. They all failed. A lot of effort went into things like CEE, or we can also use logging formats like CEF, but these are not generally being used. So it's safe to say that whatever a programmer comes up, that ends up in the logs at the end. And imagine when this programmer is from, you know, somewhere in the world where the English is not a native language. So you can imagine what kind of things we can find there. So you can ask, what can we do with literally terabytes of data? In your systems. What do we want with logs? Everything we want with logs depends on structure. We want reports, we want visualization, we want alerts, we want correlation. All of these require structure. And like I said previously, logs are by nature unstructured. So we have to find that structure in our logs. So what do we do with all this data? As a first step, we have to collect them. Without a solid infrastructure, without logs being collected, stored, and being just available as a source of information, we are doomed. So that's our first task, get log management up to speed and scale it up to the requirements of your organization. But once log management is there, we certainly want to start working with log data. And, well, the first or the oldest method of extracting information from logs is pattern matching. You probably all know regexps, regular expressions, or grep, or some similar tool that you can use to match against log messages. There are two primary goals with pattern matching. One, to identify the meaning of a given log message. Like in this case, user logged in. That's trivial to decipher. I personally saw at least 30 or 40 different ways to describe a user logged in. But probably there literally exists hundreds of ways of describing the same event. So the first goal is to identify what the log message is about. The second thing that the pattern matching engine gives us is extracting the variable information, like Joe in this case. So user logged in, that's an event, but almost all of the events have some kind of arguments or parameters which describe the event in detail. Pattern matching can be quite fast, so even if you have hundreds of thousands of messages per second, which is not unheard of, You can scale pattern matching into those speeds. Pattern matching can be quite accurate. So if you have a pattern that matches a line, then you will quite with a high chance get the information out of it. But on the other hand, patterns are difficult to write. It's usually a laborious process. It's something that you do manually. And well, that's the drawback of pattern matching. And also, pattern matching or patterns can easily deteriorate. What does it mean? Logs can change all the time. So if a pattern encapsulates a given log message very precisely, it will by nature easily break. So once the log message changes, the pattern will be of no use. Okay, we can come up with different approaches of extracting information. The next one is heuristics. We use heuristics all the time, which means that we try to extract information from log messages automatically without having to use rules. Things like email addresses or IP addresses or even MAC addresses are easy to find because they have a very defined structure. And in those cases, we can actually identify, okay, there is an email address in this log message, so I can work from there. However, these kind of heuristics are much slower than mere pattern matching. So that's a problem. Also, heuristics can fail in subtle ways. If you think about email addresses, those tend to be easily recognizable by our eyes. But if I say that message ID is usually just like email addresses, there are conflicts between things that look pretty much alike, whereas they are different things. So that's the problem with heuristics. Also, log messages tend to use quotation and escaping and stuff like that, and it's very difficult to get those right without actually describing the log message itself. So heuristics is a better technique. We don't have to work that much with them ourselves manually, but the results are not as accurate as with pattern matching. Clustering. There is one thing we cannot complain about when we are talking about logs. It's their volume. The sheer volume of logs are a problem in themselves, but given we have a lot of historical data, what we can do is try to find the similarities between log messages. Once we have a pile of messages that look very similar, not the same, just similar, we can use clustering techniques to find those that look alike and come up with patterns automatically. The best example of these clustering techniques is SLCT, which is Risto-Warrandy's algorithm. There is a scientific paper you can find easily with Google that describes how to apply this clustering mechanism to log messages. What this brings you is a number of patterns that you cannot write you don't need to write yourself, but you still need some human validation whether the patterns that came out of that process is completely alright. So message clustering helps a lot in creating patterns. It decreases the amount of work that you have to do manually, but also takes a lot of CPU power. So you cannot do this online. You cannot do this during log processing. It is something that you can do side by side your log management and processing system. Search is not strictly an information extraction algorithm per se, but we use search in connection with these things all the time. Like I said, if you have hundreds of thousands of messages per second, each heuristic that you apply comes at a cost. Your ingestion rate or your receive rate goes down because you are doing a lot of things for every message that comes in. And that's not feasible at a higher scale. So what you do usually is that you store all those messages, search on them, filter on them, and only apply the heuristics on the result set. This becomes better because you narrow down. You don't have to process 1 billion log message if a search expression can reduce the number to 10,000, and you can do much more things on that. So in general, you use a combination of pattern matching, heuristics, and maybe clustering to come up with all the patterns that you use to structure your logs. And search plays an important role there. I talked a bit about CPU usage of each of the approaches. One of them, some of them is cheap, others are more expensive CPU-wise, and therefore it's important to know where those algorithms are actually applied. You can apply these algorithms online as the messages come in, and this generally works much faster if your message rate permits it. So if you have only 10,000 messages per second, you can do pretty much everything in your ingestion path. If it goes higher, you cannot do that. It's simply a matter of mathematics. If you have 1,000 messages, you have 1 millisecond for each message to process. If you have 100,000, you only have 10 microseconds. In that case, you certainly can move your processing after the messages are stored, in which case it becomes an offline kind of processing. The problem with that is certainly that you have to read messages back from storage. In online, a message is in the CPU's cache, so it's quite hot there. It's fast to process, otherwise it is pretty cold and slower. So I enumerated a number of approaches to extract information from messages, and none of them are silver bullets. But what's worse, even if we come up with a set of patterns that we are happy with, we are not finished. Because the maintenance of these patterns is extremely expensive. It might even be more expensive than creating them in the first place. The issue is that software tends to change. So in complex IT systems, in a complex IT system, you apply upgrades all the time. And like I said, log messages are not set in stone. They are not a documented function of your application. So they will be changed even as minor releases are upgraded in your system. Also, while creating these patterns, you make typos. So human error is inevitable in these cases. And the issue with those, so there might be or will be errors in your patterns, either because an application changed, or maybe I made an error while creating a pattern. The problem is that it's very difficult to test for these kind of problems. End-to-end testing is almost impossible, and you are always interested in the rarest events. So if you want to fire an alert, you want to fire it on something that is not happening 100,000 times a day. You want to pick the one that is important to you. So if you make a typo, that alert will not fire 2 months from now, and you will not know it because you cannot test your infrastructure. End-to-end testing is slow and difficult. The other issue is when we are talking about a lot of work to do, either because we do it first when creating our patterns or during maintenance, but we prefer to concentrate on our own businesses. So we want someone who does these kind of patterns for us. And the best solution would be to buy products that are, come with a lot of patterns out of the box, and they solve all our problems. The issue I see here is that you cannot possibly have all the complexities of an IT system delegated to a vendor. You almost certainly will have a platform and various smaller products that each solve a given niche or a given scope of the problem. You cannot have a generic solution from one vendor. So divide the scope and find the best solution for each of that individually. Certainly, if vendors don't work out because we cannot find a product, we can delegate the task to integrators, to system integrators, to consultants who come up with all these patterns and the maintenance. that we can do, but again, then we didn't spare the work to be done. What I like to say, or what my advice would be about starting the work or continuing the work with log management, is to find our trade-offs and make conscious decisions on what we want to do and what we don't want to do. We definitely need a conscious decision whether a given application or a given report is worth it in our organization's view, because each pattern you write has its cost, and not just a one-time cost, but a maintenance cost as well. So I like this kind of process should be performed one step at a time. Don't try to solve the general problem, because it's too hard to solve. So split it up, make it smaller, and once you're done in a scope, go to the next one. And even if one scope, even if one problem is decided that it's worth it, you should limit your own depth. It's very easy to go into a trap where, okay, I want to do email reporting and I want to extract information from all the email related log messages, but that's simply too much work. If you only want sender and recipient reports, you don't need anything else. Just concentrate on the log messages that you're really interested in and nothing else. And also realize your limits. As I said, things related to logs are hard because there are tons of them, because they are diverse. There's a lot of problems that ensue if you start it broadly, and if you have two guys working on it, it will not work out. You cannot solve the general problem. Try to scale, try to focus the resources you have. So you could say you might be a bit disappointed because I didn't solve this problem to you, but my aim originally was we can see a lot of products that claim that this is a simple thing, you put there a check mark and you are done. You buy a product and you are ready. This is not true. This is not how it works out. In my view, we need a paradigm shift with regards to logging. Log is not the one true source for information. We need to integrate information silos. Logs are not something where the structure can be found. Find the structure in your organizations elsewhere. Use HR systems. Use identity management systems. Maybe even use specialized applications and find the entities, find the objects that you're really interested in. Be those users, be those hosts, be those some kind of other entity. Find the objects and enrich and augment this information base from logs. So always go to logs with a specific angle. Go there because you want to know something related to an object that you already know. And don't try to find this structure in the logs themselves. Once you identify these entities, you can always try to profile them and build a baseline. See whether a user logs in from 8 to 5 during the day, or he usually works in the evenings after dinner. If you know that on a per user basis, you can always find changes in the behavior. And these changes are the ones that you would be most interested in, not just the static reports that we usually see from logs being done. Tools of the trade, so what kind of tools are we using in this case? That's baselining, machine learning, text mining, and all the nice words when we talk about artificial intelligence. But logs are not enough for that. You need other sources of information. So basically that's what I wanted to say as a summary. Always know what you are after. Try to find the rationale behind why you're doing a given pattern. Throw it away if it's not worth it, because maintaining it will not be an easy task. One step at a time, always, yeah, well, less is more. Basically, that's what I wanted to say. And always beware of the maintenance burden and don't try to do too much. That's it. Thank you very much.